This is a recast of the 5,900-word piece, Neural Networks in Artificial Intelligence from Shinpat AI. This article discusses the history, advantages, and applications of neural networks, NNs, and AI technology used for image recognition, speech recognition, natural language processing, decision-making, and predictive analytics. Let's listen in.
Artificial intelligence, or AI for short, is the creation of machines that can complete tasks normally done by humans, and it's been evolving since its inception.
But of all of the AI technologies, the most important are neural networks, or NNs. They simulate the structure and function of the human brain to recognize patterns and classify data.
NNs are like a computational model that can learn and improve its performance over time. So what is a neural network exactly?
In essence, neural networks are algorithms designed to simulate the behavior of the human brain. They're composed by layers of interconnected artificial neurons, and each one has a weight that determines its significance in the network.
Training is a process in which the network is fed data to learn and identify different patterns between input and output. Once it's trained, NNs can be used in tasks like recognizing images, speech, making decisions, and even predicting future events.
The importance of NNs in today's world comes from their ability to process data, recognize patterns, and make predictive analytics. They're already being used in various industries like healthcare, finance, manufacturing, and transportation.
In healthcare, NNs are used to analyze medical data and predict potential diseases. In finance, they're used for fraud detection, credit scoring, and investment forecasting. In manufacturing, they help optimize production processes and reduce operational costs. Finally, in transportation, they're used to optimize routes, reduce traffic congestion, and enhance the safety of autonomous vehicles.
Another important type of neural networks is the convolutional neural network, or CNN. They were developed for image recognition tasks and are composed by multiple layers, including convolutional layers, pooling layers, and fully connected layers.
CNNs have shown impressive performance in image recognition tasks like object detection, face recognition, and medical image analysis. But they're also being applied in other domains such as natural language processing and audio signal processing.
The history of neural networks dates back to the 1940s, when Warren McCulloch and Walter Pitts developed the concept of a threshold logic neuron with binary inputs and outputs. Later, John Hopfield created a system for pattern recognition and optimization in the 1980s.
And in the 2010s, deep learning algorithms using large neural networks became popular with their ability to extract features from raw pixels.
That's right. And the article mentions several major developments in the field of AI that have come up since then. One of them is reinforcement learning.
So, what is reinforcement learning?
As the article mentions, it's a trial and error approach to teaching machines how to perform specific tasks. A machine is given a reward or penalized based on its actions and learns to adapt accordingly.
And what has it been used for?
Reinforcement learning has been used to create intelligent agents for complex tasks such as playing Atari games and defeating professional players in games like Go and poker. It's also been employed in the use of deep reinforcement learning, which involves the use of deep neural networks to further improve agent performance.
So what are neural networks?
Neural networks are computational models inspired by the structure and function of the human brain. They consist of neurons, which are connected processing elements that receive input signals and apply mathematical functions to them. The connections between these neurons are adjusted through a process called training to teach the network to recognize patterns and make predictions.
Got it. So how have neural networks evolved over time?
Neural networks have evolved a lot since their inception in 1950. Single-layer perceptrons developed in 1950 were only able to classify linearly separable data, but multi-layer perceptrons in the 1980s allowed for more complex classification tasks.
Interesting. So what kind of applications are neural networks being used for?
Neural networks have been used in image and speech recognition, natural language processing, drug discovery, and autonomous driving. Transformers, a type of deep architecture, have enabled language modeling, machine translation, and text generation with better precision and speed than traditional methods. In autonomous driving, neural networks must be able to handle safety-critical scenarios effectively and provide transparent decision-making processes, so interpretable neural networks are an active area of research as well.
Yes, it's exciting to see all the potential applications of this technology.
Neural networks are composed of interconnected processing nodes called neurons that process input data through a series of layers. Each layer identifies features in the data, and the network adjusts its connections and weights to improve accuracy. This ability to continuously learn and improve is what makes neural networks so powerful. There are various types of neural networks, each with their own unique characteristics and applications. Feed-forward neural networks are the simplest type of neural network and are used in pattern recognition and regression problems. Recurrent neural networks, on the other hand, have feedback loops that allow them to remember previous inputs and outputs over time, making them suitable for applications such as speech recognition and natural language processing.
Convolutional neural networks are well suited for image and video recognition tasks, while self-organizing maps are used for clustering and pattern analysis. Adversarial neural networks consist of two neural networks, a generator and a discriminator that compete with each other in a zero-sum game to produce realistic outputs.
That's right. Understanding the different types of neural networks and their specific applications is critical to developing effective AI systems. One of the main differences between feed-forward and recurrent networks is their structure. In feed-forward networks, the data flows from the input layer through one or more hidden layers to the output layer without any feedback loops.
In contrast, recurrent networks have feedback connections that allow information to circulate within the network. This means that recurrent networks can use previous outputs as inputs to predict subsequent outputs, making them well suited for tasks that involve sequences or time series data.
While feed-forward networks are typically faster and easier to train than recurrent networks, they may not be suitable for tasks that require temporal modeling or long-term dependencies.
It's important to keep in mind, too, that with all the potential of these technologies come ethical concerns related to the use of AI, such as privacy violations and algorithmic bias. We have to make sure we're considering all sides of this technology when we use it.
Absolutely.
It's amazing how much they can do. CNNs have made significant strides in tasks like face recognition, object detection, and medical image analysis. But they're also being used to improve autonomous driving systems, robotics, and even drug discovery.
And with the availability of data and computing power, the potential uses of CNNs are only growing. That said, we have to make sure we're using this technology responsibly. That means considering the potential risks and downsides as well as the benefits.
So what exactly are the applications of neural networks? Well, they have a wide variety of uses. In image recognition, for example, neural networks are used for object recognition and classification, face detection, and even medical image analysis. They can also be used in natural language processing to analyze and understand human language, enabling the development of chatbots and virtual assistants.
They're also used in finance and economics to predict stock prices and identify market trends. And neural networks are used in recommendation systems like Amazon, Netflix, and Spotify, which suggest products or content based on the user's preferences and behavior.
And as if that weren't enough, neural networks are increasingly being used in autonomous driving and robotics to enable machines to learn and improve their performance over time.
We're seeing them used for route planning, decision-making, motion control tasks, all critical for autonomous driving.
Right. And neural networks have predictive modeling capabilities that can be used in finance, healthcare, and marketing.
We're also seeing them being used in medical diagnosis. Neural networks can analyze vast amounts of patient data to identify patterns and relationships between symptoms, diseases, and treatments, allowing medical professionals to make more accurate diagnoses faster.
Right. So AI can be used to help us make more informed decisions about patient care. But we have to remember to use this technology responsibly, considering both its capabilities and potential ethical implications as well.
Absolutely. Neural networks have advantages and disadvantages to consider, and they come with their own set of ethical complexities.
So let's break it down. What are the advantages of using neural networks over other machine learning algorithms?
Neural networks are incredibly powerful because they can learn and adapt to new data sets with minimal human intervention. They're also able to recognize patterns and features that are not easily detected by traditional algorithms, and they can generalize results and make accurate predictions even with incomplete or noisy data. This makes them incredibly useful in a variety of fields, including image and speech recognition, natural language processing, and predictive analytics.
Those are some impressive capabilities. And while they're incredibly promising, we also need to consider potential drawbacks. What are some of the limitations and disadvantages of neural networks?
Well, for one, they're computationally expensive and require significant hardware resources for training and deployment, which can be a barrier to entry for smaller organizations or individuals. Another big issue is that neural networks can be difficult to interpret and debug. Their decision-making processes are typically black box in nature, so it can be difficult to know why a neural network produces a given output. Finally, there is always the risk of overfitting when using neural networks, particularly in cases where there is a limited amount of training data available.
Those are all valid points to consider. Are there any ethical concerns associated with the use of neural networks?
Absolutely. One major ethical concern is the issue of bias. Neural networks are only as unbiased as the data sets that they are trained on. So if the data sets contain biases relating to race, gender, or any other protected characteristics, then there is a risk that the neural network will perpetuate those biases. Additionally, the use of neural networks can raise issues regarding privacy. There is the potential for neural networks to be used to collect and analyze personal information about individuals without their consent.
Those are definitely important issues to consider before using any type of AI or machine learning technology. So what does the future hold for neural networks?
The use of neural networks is growing rapidly due to their powerful capabilities. In the future, we could see them being used in autonomous robots, prosthetics, assistive technologies, and many more applications. However, it's important to remember that any new technology comes with ethical and social implications, so it's crucial that researchers consider potential drawbacks and explore ways to mitigate them as they continue to develop this technology.
That's a great point. Thanks for bringing that up.
We're also seeing neural networks being integrated with other technologies, like cloud computing and the Internet of Things, to create more dynamic systems. In the future, researchers are looking to build more interpretable models that are able to explain their decision-making processes, as well as developing methods for training neural networks with less data and more robustness.
It's clear that research and development are key components in building better neural networks and bringing the potential of this technology to life. Over the past few years, we've already seen some amazing breakthroughs in various fields, including healthcare, finance, and transportation.
Absolutely, neural networks have already been deployed in areas such as image recognition, natural language processing, and predictive analytics. In healthcare, they can be used to diagnose diseases, predict patient outcomes, and develop personalized treatment plans. They can also be used to detect fraud in finance, optimize traffic flow in transportation, and improve road safety.
It's clear that neural networks are changing the way we live and work, but how do they actually work? Well, deep learning algorithms use the concept of neural networks by creating a vast number of layers that can process large amounts of data in a hierarchical fashion. The weights of each layer are adjusted through a training process to optimize prediction accuracy and increase speed for real-time applications.
Finally, let's talk about some of the challenges that researchers face when building better neural networks. Overfitting is one of the most common challenges that they need to overcome. This is when the model has too much information and is unable to generalize its predictions, leading to poor accuracy levels.